and gentlemen, we're working with a live audience. No, I'm not doing an operation on any student here, but we are going to do a live show here. So today we are taking a look at inertia and Newton's first law of motion. And what is Newton's first law of motion? Who can tell me that? Speak loudly. Got to yell it out loud.
An object stays at rest unless it is acted on by another force.
Well, that's half of it. An object will stay at rest, and it wants to stay at rest. But an object also what?
In motion will stay at motion.
In motion will stay in motion unless acted upon by another force. That's right. What makes this object stay in motion? What makes that object at rest? One word.
Inertia.
Inertia. And inertia is related to what? Mass. So in this experiment, we are going to demonstrate this fact, this law, this Newton's great law, his first law. So to do that, you're going to collect some data in a data table. You're going to collect the mass of this car. So get ready in your data table. There's going to be a mass of the car with no marbles, the mass of a car with one marble, then two marbles, then three marbles. So here we go. The mass of one car with no marbles is 56 grams. Record that in your data table. The mass of a car with one marble is 84 grams. Record that in your data table. The mass of a car with two marbles is 112 grams. Record that in your data table. A mass with a car, the mass of a car with three marbles is 141 grams. Record that in your data table, please. Now, let's take a look. I have my timer set up. We are measuring in seconds. You are going to have to make sure that you are converting your distance, when you're creating your speed data, that you are calculating speed in meters per second. So be careful. That decimal is going to move there, okay? All right. Let's first of all collect the data for the speed of this car with no marbles. Here we go. We got 0.0043 seconds. Now, as you are calculating your speed, remember, that's distance divided by time. The distance is 1 centimeter because of this flag. The time is 0.0043. When you do the math, distance divided by time, make sure you move that decimal to reflect meters per second. All right, be careful. Make sure you do that. The car with one marble. Here we go. We are now adding mass. What are we doing to inertia here, ladies and gentlemen? I added a marble. What happened to inertia? Yell it out. The inertia, did it increase? Inertia increased. What should we see happen with speed? Hypothesize. Think about that for a second. Here we go. 0.0058. Record that in your data table. The car with one marble, 0.0058. Car with two marbles. Here we go. You. Don't get away from me. See? Here we go. 0.0062. Record that data in your data table and then calculate speed. The car with three marbles. Car with three marbles. Here we go. We are now tripling the amount of inertia, aren't we?
Yes.
More inertia. What should we see happen to the speed? Will it go faster, slower, or stay the same? Remember what I said in terms of amount of force to get this thing moving? Think about a grocery cart. When you start grocery shopping, you have an empty cart. Is it easy to push?
Yes.
So if I'm pushing that cart with the given amount of force, and now my wife comes along and starts throwing all kinds of stuff in it, now I got a full grocery cart, and I'm pushing with the same amount of force, is it easier or harder to get that cart moving from a dead stop?
Harder.
It's harder. So think about that. We've increased inertia. Inertia wants to keep the car at rest. We want to set it into motion. Here we go. We're going to set it into motion. 0.0069. 0.0069 for 3 marbles in the car. Collect the data and finish the lab. And there you have it. Here is at work, a car with increasing inertia. We notice what happened to the speed. From 0 marbles to 3 marbles, what happens to the speed? It slows down because of inertia, right? All right, finish the lab. See you next time.